The United States Code, or U.S. Code, is the official collection of all the permanent laws of the United States, organized into 54 titles and spanning over 240,000 pages. This vast legal corpus is essential for understanding federal statutes, but it presents significant challenges due to its complexity and the specialized language used. One major issue is that legal terms often have precise definitions that differ from everyday meanings, and these definitions are scattered throughout the text, not always easy to find. In this research, the authors, Arpana Hasabatu and Harsh Shah from Cornell University, developed an advanced system to automatically extract these statutory definitions using transformer-based natural language processing models. They focused on improving upon earlier methods that relied on traditional machine learning features, which weren't as effective with the nuances of legal language. The core of their approach uses a model called Legal-BERT, which is a version of the BERT transformer architecture pre-trained specifically on legal texts. This makes it better suited for understanding the formal and context-dependent nature of statutes. Their system processes the U.S. Code, which is available in XML format, allowing them to analyze its structured layout. The process begins with a multi-stage pipeline. First, the system examines each paragraph in the U.S. Code to determine if it contains a definition. They fine-tune the Legal-BERT model on a dataset of legal texts, training it to classify paragraphs accurately. For instance, it looks for patterns like phrases that introduce definitions, such as the term, word, means, or other legal conventions. Once a paragraph is identified as potentially containing a definition, the system aggregates related paragraphs into what they call coherent definitional units. This step is crucial because definitions in legal texts can span multiple sentences or even sections, and they might include contextual details like exceptions or cross-references. Next, the system employs a combination of attention mechanisms and rule-based patterns to extract the key elements. Attention mechanisms, which are a feature of transformer models, help the system focus on the most relevant parts of the text, such as the defined term itself and its explanation. Rule-based patterns add a layer of precision by incorporating legal-specific rules, like identifying jurisdictional scopes, for example, whether a definition applies only to a certain title, section, or context. This method addresses several challenges highlighted in the paper. For one, definitions aren't always in a single, convenient location, they're distributed across the corpus. The system handles this by mapping definitions to their usage contexts. Additionally, the same term might have different meanings depending on where it's used, so the model determines the scope, such as whether it's limited to federal law or applies more broadly. To evaluate their system, the researchers tested it on multiple titles of the U.S. Code, which contained thousands of definitions. They compared it against previous approaches, like traditional machine learning classifiers. The results were impressive. Their best model achieved 96.8% precision, 98.9% recall, and an F1 score of 98.2%. This means it was highly accurate in correctly identifying definitions while minimizing errors, marking a substantial improvement over older methods. The paper emphasizes the importance of this work for making legal information more accessible. By automating the extraction process, it reduces the need for manual effort, which is time-consuming and requires expert knowledge. This advancement not only helps legal professionals and researchers but also supports the general public in understanding complex laws. For example, in Title VII of the U.S. Code, which deals with agriculture, there are over 1,800 definitions. Manually sifting through these would be overwhelming, but this system can quickly identify and organize them. The authors also note that this extraction technique lays the groundwork for other legal AI applications, such as named entity recognition or downstream legal reasoning tasks, where understanding definitions is a foundational step. In building their model, they drew from resources like the Legal Information Institute at Cornell University, which provides free access to legal texts. This integration highlights how technology can enhance public access to justice and improve the comprehension of statutory law. Overall, by leveraging state-of-the-art NLP tools like transformers, this research demonstrates how AI can tackle the intricacies of legal language, making it easier to navigate and interpret the ever-growing U.S. Code. The use of domain-specific models like Legal-BERT shows the power of adapting general AI techniques to specialized fields, leading to more reliable and efficient outcomes in legal information extraction.